Alright, so we're beginning a new unit here on piecewise functions. So these are maybe exactly what they sound like. They're functions that have different behavior because they're made up of different pieces depending on which x you're looking at. Okay, so they're made up of different pieces at different x values. So let's see what we mean by that. So what we see here is a really simple example. And this one is like maybe not that useful, but we'll see some more challenging examples a little bit later that are a little bit more useful in terms of like real life stuff. So we have this line that is clearly the line f of x equals -4 or y equals -4, right? But we see that at x equals, looks like -3, we have a dot actually at -6. So this point, -3, comma -6 is also part of the function. Okay, so if I made a little table to describe this function, it would look pretty much just like -4 all day, right? So no matter what x value I pick, I get -4, right? And that makes sense because it's a horizontal line. Except we have this exception here, right? So -3 is defined as -6. Okay, so this function is defined in a particular way. So we no longer have to use just one equation to define functions. We can do whatever we want. Okay, so this is the weird point. -3, -6. So the way we'd write this function down is we'd say, we'll call f of x. F of x, and we might use a little bracket here, is equal to -4 for x not equal to -3, and then is equal to -6 for x equals -3. Okay? So this statement says that for everywhere on the graph of f is equal to -4 except for at this one spot. Okay, so we can write this down in a certain way. All you're doing in this lesson, this is going to feel very easy, sort of suspiciously easy. It's not rocket science. You're just reading values off the graph, right? So if I asked you to find x equals -8, you'd say f of -8 equals -4. But if I asked you to say x equals -3, you would say f of -3 equals -6. Okay, so you're just reading them off the graph, and then the graphs look weird because they're weird piecewise functions. So let's look at some examples here. We'll just do a couple quick ones. This is, again, very easy. So what they might tell you on Delta Math is they might say find f of -1. Okay. So you would read it off the graph. So -1 is obviously right here, and then I read the point that is part of the function. So I'd say f of -1 equals 3. So that's one example based on this graph. Or they might say find f of 1. Well, x equals 1 is right here. And notice here is the piece that is not defined as this parabola, right? F of 1 equals -3. Because this point is 1, -3. So that's it. There's one complication here. So here is an example straight off of Delta Math. So we're finding f of 2. F of 2, notice x equals 2 is right here, is actually between these two pieces, right? So f of 2 is undefined, we'd say. Or maybe on Delta Math it says does not exist, DNE. So that's it. These are piecewise functions. We're going to make these a little harder as we go, but not much harder than this. We're closing out the year on something fairly accessible.